Hello and welcome. Today, we're diving into a really cool new AI from NVIDIA that's learning to see and hear the world at the same time, kind of like we do. So, to really get why this is such a big deal, let's start with a basic question. Does the AI we have today have blind spots? And the answer is a resounding yes, especially when it comes to just perceiving the world around it. And that brings us straight to the heart of the issue, what we can call AI's perception problem. I mean, think about it. If an AI can't perceive the world accurately, how can it possibly reason about it correctly? Check out this example. Imagine an AI watching a video of a deep-sea expedition. Just using its eyes, it might say, "Oh, that's a blue underwater robot." Okay, then you have another AI, this one only listening to the audio, and it hears the narrator talking about exploring Earth's interior. In their own little bubble, they're not totally wrong, but they're both completely missing the real story. Researchers have a name for this, modality-specific hallucination, and it's a huge blind spot for AI right now. So what's the fix? Well, the team at NVIDIA thinks they've cracked it by building an AI with a more complete set of senses. The solution is something called Omni-Modal AI, and the whole goal here is to build a system that can process sight, sound, and text all at once. The same way you see lightning and hear thunder, and your brain instantly connects the dots to understand, oh, there's a storm. And that's exactly what NVIDIA's new open-source model, OmniVinci, is designed to do. But how does it actually work? What's the secret sauce here that lets OmniVinci blend these different senses together so well when others have kind of struggled? Let's break it down. It really boils down to 3 key steps. First, you've got to align the senses. Basically, teach vision and audio to speak the same language. Second, it has to understand time, making sure what it sees and what it hears are perfectly in sync. And third, you have to feed it a much better diet of data to learn from. So for that first step, they use this really clever bit of architecture called OmniAlignNet. The best way to think of it is like a Rosetta Stone for the AI senses. It takes all the visual information and all the audio information and maps them into this shared space, teaching the model that, hey, the sight of a dog barking and the sound of a dog barking are actually the exact same thing. Next up is the challenge of time. Without getting the timing right, an AI might hear the sound of a glass shattering a split second after it sees it break, and it would fail to connect the two events. OmniVinci gets around this by essentially timestamping all the incoming data, which guarantees that sights and sounds are perfectly synced up just like in the real world. And finally, there's the data itself. You know that saying, "you are what you eat"? Well, it's 100% true for AI. OmniVinci was trained on this super diverse diet of 24 million samples. But look at that chart, that crucial 15% of omni-modal data, the stuff that explicitly links sight and sound together. That's the key to building a really robust understanding of the world. Okay, so that's the theory. Sounds great, right? But does it actually work in practice? Let's take a look at the performance numbers. Whoa. Okay, so on the DailyOmni benchmark, which is designed specifically to test how well an AI connects sight and sound, OmniVinci doesn't just win, it absolutely crushes the competition. It scored a full 19 points higher than its closest rival. That is a massive, massive leap forward. But here is where it gets even cooler. It's not just about combining senses. On this other benchmark, one that's purely for video comprehension, so vision only, OmniVinci still sets a new state-of-the-art score. This tells us that teaching an AI to listen actually makes it better at seeing. The senses really do work together. And maybe the most impressive part of all of this? The efficiency. OmniVinci got these incredible results using 6 times less training data than its main competitor. This is such a big deal because it proves that a smarter architecture can be way more important than just throwing more and more raw computing power at a problem. So, a smarter, more efficient AI that can see and hear. What does this actually unlock for us in the real world? Well, this level of performance opens up some pretty incredible new doors. The possibilities are seriously exciting. Imagine robots that can actually understand what you're saying to them while also seeing their environment. Or think about a medical AI that can analyze a CT scan while simultaneously listening to a radiologist's spoken notes. We could even see things like smarter factory monitoring or AI that can generate sports commentary on the fly. And as the researchers themselves put it, the senses reinforce each other. Training an AI with both sight and sound just makes the entire learning process faster and better. It turns out that for AI, just like for us humans, Two senses are way better than one. So, all of this brings us to one final, pretty mind-bending thought. We're watching AI gain more and more human-like senses. The question isn't really if AI can perceive the world like we do anymore. The question is, now that it can, what should we build next? What new frontiers does this open up? It really makes you think.